Okay, can. You can see my shared screen?
Yeah.
Can? Okay, good.
Yeah.
Good. Okay, and let's go through. So the first question that you got slightly wrong is question 4. So let's just go through the paper one. Question 4. For the percentage change, right? Actually, technically, it should be V new minus V old divided by V old. I think you use N and O to represent new and old. You need to include this part here. Okay, this part here in the working, divide by VO. Then you times 100%. Of course, 100% is just 1, so actually you don't need to write it. Okay, but I think you did it inside your head. You divided by VO. I show you the working there. Okay.
Oh, okay.
And next thing you need to know for question 7C. Okay, question 7C. You need to remember, or 7D, sorry. You need to remember how to draw all of the family of power functions and exponential functions. What do I mean by that? I mean, for example, y equals to kx power n. Then the n here, it can be either -3, -2, -1, 0, 1, 2, or 3. Do you know how to draw the graphs?
No.
No? Okay. Do you know something called Desmos? Desmos.
Is the graph calculator, right? Or is the...
Yeah, it's a graph calculator. Wait, my screen sharing is paused, is it? Oh, sorry. Can you see my screen?
Yeah, I see the smiley face.
Okay, good. Let me just share the Desmos page. Okay, so this is Desmos, the website. Then what you can do here is you can just draw a graph. So let's say I choose a number, let's say 5. Then I have x to the power, it's a caret, number 6 on the keyboard. Then you press n. Then you can choose values of n. Okay, let's take a look. Let's say I change the value of n to go from -3 to +3. Step size is 1. Step size 1. Okay, then you can change the different value of n and you can see the different types of graphs. Can you see? I zoom out a bit. Yeah, your for O levels, you're supposed to have memorized all this already, huh? Yeah, in case I think you forgot about it, but you need to remember the graph, how each of these curves look. Okay.
Okay.
Yeah. Next one will be exponential. Let me hide this. The next one is exponential. So let's say I give a random constant, let's say 4, doesn't really matter. Then you multiply it by some other constant, let's say 2. Then you raise to a power of x. Can you see the graph, the green one?
Yeah.
Yeah, that's an exponential curve. You also need to remember that. So there's what we call this y equals to 0, this x-axis. This one purple line is the equation of the x-axis. That's what we call an asymptote. Do you know what's an asymptote?
No.
Okay, asymptote basically means as the x value gets closer and closer to a certain value, in this case for exponential, as x gets smaller and smaller until negative, a very, 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 very small negative number, what you realize is that what happens to the y coordinate? It starts at 0.041, 0.018, 0.005, 0.002, so on and so forth, 0.001. What's the pattern? Can you see the pattern? What value does it eventually reach? Can you see the pattern?
Say again.
Like as the x value decreases, you see the green color graph. Let's hide the purple one. As the x value decrease from 1.1 to 0.8 to 0.3 to 0, focus on the y coordinate. What happens to it? Is it increasing or decreasing? Increasing or decreasing?
Decreasing.
Decreasing, yes. So as x gets smaller and smaller, you realize it's decreasing. Eventually, it reaches what?
0.
Reaches what value? 0, yes. But actually, it's due to the inaccuracy of this graph. If you zoom in close enough, right? Actually, it's not 0. Actually, it's not 0. It's slightly above. It's 0.001 or 0.00000, many zeros followed by a 1. Okay, it's getting very, very close to 0, but not exactly 1. Then that's what we call an asymptote. Asymptote is either a horizontal line or a diagonal line where the graph gets closer and closer towards it but never touches it. Okay, that's an asymptote, something new. All right, you need to know how this exponential curve looks for Amax as well. Okay, let me just change the screen back to my iPad. Then I can annotate. Okay, next question that you got wrong. Oh, right, I should go through 7D as well. So for 7D, hold on, let me find the question paper. Question 7D, what did they exactly ask you to find out? Is it 7D or is it 8A actually? Oh, sorry, I messed up. It is supposed to be 8A. 8A. Okay. 8A, what did they ask you to draw? They asked you to draw a graph of what is it? Let me see. Okay, they're asking you that to draw the graph of P equals to K over V. All right. Sketch the graph of P against V on the axis provided. So over here, due to practical reason, you can't have negative volume, correct? So that means that on your X and Y axis, or rather your P and V axis, P is the vertical, V is the horizontal. This part here on the left, right, impossible. You can't have a graph because these are the negative V values. Can you have a 0 for V? Can we have a 0 for V? Is that possible?
No.
Why cannot? Because here it's a divide by 0. Can you divide by 0?
No.
No, cannot. Yes, exactly. So that's why over here, right, that's what we call a vertical asymptote. Okay, here. X equals to 0. What we call a vertical asymptote. Vertical means up, down. Oh, vertical means up, down. Oh, I got an extra T. Okay, so the graph cannot touch this asymptote. Okay, so let's think as V increases, what happens to P as your denominator increase? We already figured out the value of K. We already figured out the value of K to be this 32. So let's just replace it with 32. Just try with a few numbers. 32 over 1, 32 over 2, 32 over 3, 32 over 4. What happens? Increase or decrease?
Decrease.
Decrease, right? So that's why the graph should curve downwards like this. But should it curve? But there are 3 ways to go to decrease, right? It's either curving like this, or like this. Which one do you think is the correct option? A, B, or C?
C.
C, exactly. Okay. It can't be linear because if it's linear, you'll get a y equal mx plus c. If it curves this way, it means that you have to continue all the way until you hit this point here, which means that your pressure will get to negative. And also, it's impossible for pressure to be negative by physics definition. So that's why the only option is C, and it must look something like the following. Curve like this. Okay, and there's another asymptote. Can you see another asymptote?
Horizontal asymptote.
Yes, it's over here. Just like the exponential, there's also another asymptote. It's y equals to 0. Oh, sorry, not y. We should change the letter. It should be p, and not x. It should be v, right? Because we changed the variable here, so we must change accordingly. So this is the equation p equal to 0, which is your horizontal asymptote. Then, is it clear so far?
Yeah.
Yeah, so that's just how you sketch it. Let's see, the next question you got wrong. Let me see. Question, is this 9 or 10? Oh my goodness. Question 10, 10B, I think. Right, 10B, yes. Number pattern. Okay, let's see the number pattern. Question 10B. So you got 1 plus 3 equals to 4 equals 2 times 2. Then you got 1 plus 3 plus 5. This one is equal to 9 equals to 3 times 3. Can you see the pattern? Can you see the pattern? It's just perfect square. This is 2 square. This is 3 square. Then 4 square. Then 5 square. So on and so forth. Can see, right? Yeah.
Yeah.
Yeah. So here the number pattern, right? They are asking you 1 plus 3 plus 5 plus 7 plus 9. Basically, you see it's all the odd numbers until, let's say, 79 and then 81. The trick here is to identify the pattern in general. So let's take a look at the first line. 1 plus 3 equals to 2 square. How do you link 3, the last number, to 2? Maybe initially you might say minus 1, right? Minus 1.
Yeah.
But does that pattern hold? Let's check the next one.
Because
5 go 3, cannot, minus 2 already.
Yeah.
So what's a better way? Should I give you some time to think, or should I just review the answer?
Then I think you can just review.
Okay, I'll just okay, save time. So how do you link 7 to 4? How do you link 5 to 3? The pattern is really simple. You just need to take the last number plus 1 divided by 2. So let's see. This 4, right, is really just 7. You plus 1 to it, then divide by 2. Correct or not? 8 plus 1. Sorry, 7 plus 1 is 8. 8 divided by 2. Gives you 4.
Oh, okay.
Then how about the sum from 1 to 5, the odd numbers? Same thing. 3 here is take the 5, you add 1 divided by 2. Correct?
Yeah.
Then likewise, the first line one, just to fill in the blank, I think you get it already. Take the last digit, which is 3. Then you write 3 plus 1 divided by 2. That's your 2. Okay? So in general, let's see, if you have 81, it's equal to what? It's equal to something multiplied by another thing. These two numbers are the same. So our goal is to find out what is one of this number. Then we just square it. Or more simply, it's just that number square. How do you find that number? How do you find that number?
What
would this number be? Okay.
41.
Not really. Correct. Sorry. Yes, you're correct. Let's go. Yeah, you just take the 81. You add 1 to it, then divide by 2. It's a 40. Yeah, 41. Correct. Sorry. So you get a 41. Then you just have to square it. Then the answer will be 41 square. Let's see what is it. 1681. Okay? Okay, good. Next. What's the next one you got wrong? Okay, question 11. Not a major mistake. It's for money questions, you always round off to 2 decimal places. But yeah, not so important. That's only for O levels. You're not taking O levels already, so not important. Also 14B, 14A, you need to give simplest form of 10 over 8 is 5 over 4. But also not so important anymore. Okay, good. You know how to complete the square. Okay, question 16. Here we go. Okay, I think this one is the main one that you are confused by. Let me start a new page. Question 16. Let's go. So I'm just gonna use black pen now. Let's take a look. Okay, I'll just recap quickly with you the few things you need to know for trigo. First thing, tuakaso. Do you remember tuakaso?
Yeah.
Okay. So let's just do a quick example. Let's say this is the angle. This is 3, this is 4, this is 5, this is 90 degrees. Sine theta is?
Sine theta would be opposite over hypotenuse, so 4 over 5.
Good. And cosine theta?
Cosine would be 3 over 5.
Tangent?
Tangent would be 4 over 3.
Perfect. Good. Okay. So this is your tuakaso. Then let's say that you now have a obtuse triangle like this. This angle here is your theta. Then you have, I think you can see that there's this small acute angle here. Right? Let's just call it alpha. This is a little fish. It's a Greek letter, alpha. Usually we use Greek letters to represent angles. And there's a 90 degrees. Then let's say that, can you see this right angle triangle here?
Mm-hmm.
Okay, I'm gonna label some of its length. This is 5, this is 12, this is 13. You can verify using Pythagoras theorem that is correct. You remember Pythagoras theorem?
Yeah.
Yeah, 5 square plus 12 square equal to 13 square. Right? Yeah. Okay, great. Just believe me that the lengths are correct. Okay, so now let me ask you. If I ask you for sine theta, cosine theta, and tangent theta this time, what would it be?
Okay. I forget the rules about this.
Obtuse angle, yes, it's a rule you need to remember. And if you're taking Amax, right, actually, we will extend the theta, right, to all angles. In Emax, you're only restricted. Let me just tell you, in Emax, you're only restricted to 0 degrees less than theta less than 180 degrees. And theta will not be 90 degrees. Okay, these are the only kind of angles you're dealing with. But in Amax, you're generalizing trigo, a more difficult version of trigo, where the theta can become any angle. It can even be negative. Did you know that? Can also be negative. Probably not. Emax not tested. I'm not sure whether you've learned anything else beyond Emax math content. You said you went. Okay. You said you didn't really study anything else, right?
Yeah. No.
Okay. Okay. Then never mind. I'll just start from the Emax content, then slowly build up to the Amax one. So first thing you need to learn from, you should already know from Emax is that whenever the theta is obtuse meaning it is more than 90 degrees, i.e. 90 degrees less than theta less than 180 degrees, then you need to follow this rule. Whenever you got obtuse angle this theta, you have to go back to its acute angle alpha. Can you see this angle alpha? Alpha plus theta adds up to what?
180.
Very good. Okay, good. And that's how you identify your alpha. Then for sine, it will always stay positive. For cosine, you also do the same thing, cosine alpha. For tangent, you also do the same thing, tangent alpha. However, you need to remember this rule: plus, minus, plus. Okay? Plus, minus, plus. Sorry. Plus, minus, minus. Let me double confirm. ASTC. Yeah, plus, minus, minus. This is the correct one. Meaning, let's just see how do we use this formula. Sine of theta will be exactly the same as sine of alpha with a positive sign. Of course, you can just ignore the plus sign. Then in this case, what sine of alpha? So, can you tell me? Sorry, mic test, can you hear me? Oh, I cannot hear you. Can you hear me? I cannot hear you.
Hello.
Okay, I can hear you now. Yes.
12 over 13.
Okay, good. 12 over 13. Okay, good. How about cosine alpha? What's cosine alpha?
Cosine alpha would be negative 5 over 13.
Okay, good. Negative 5 over 13. Oh yeah, can I ask? Just now the audio disruptor. What happened?
Oh, I'm not sure what happened.
Sorry.
I'm not sure what happened.
Oh. Okay. Cause I'm scared. Later I talk for 2 hours and then I cannot hear you. Then I talk to myself. Very dangerous. Okay, I better audio check every time. Yeah. Can you hear me? Yes. That's the main problem with online lessons. Okay, Ken. Yeah. So it's just 5 over 13, but don't forget this rule. You need an extra minus sign for obtuse angle. Okay.
Okay.
Ken. Then for tangent, negative sign put down first. Then tangent alpha will be
Negative 12 over 5.
Yes, exactly. Opposite over adjacent 12 over 5. Of course, if this was Emax, then you have to write in mixed numbers. But you're not taking exam anymore. I mean, not for beyond Emax. Nobody cares about whether you convert into mixed number or not. You can leave it as an improper fraction. Like the numerator bigger than denominator is perfectly fine. Okay? Yeah, this is perfectly fine. Okay, that is the rule. So now we can begin doing the question. So what you realize is that this question is very tricky. Here I gave you a right angled triangle with actual length, like 3 cm, 4 cm, 5 cm, 5 cm, 13 cm, 12 cm. But in this question 16, very tricky. They did not give you the actual length. They gave you a triangle. They gave you a triangle, and then they gave you sine of the angle. Let me draw the diagram first. Okay, they tell you sine of angle A is 5/13. So what does that tell you? That means you must, if you refer back to what I did just now, I always have the angle alpha. So you must also label angle alpha. Okay? Can? Then when they tell, then you must remember the rule, right? I wrote it over here. Sine of an angle obtuse is just sine of the acute angle, but positive. Not but, it's the same. So that means that sine of A is actually just exactly the same as sine of alpha with a positive sign.
Okay.
Equals 5/13. Then in that case, here you will conclude that sine is opposite over hypotenuse. So sine alpha equals 5/13 means 5 here, 13 here. Correct?
Okay.
Technically not correct. Okay. It should be 5x and 13x. And the last one will be, if you use Pythagoras theorem, it will be 12x. Where x can be any number. Okay. So it can be if x is 1, then it will be 5 cm, 12 cm, 13 cm. If x is 2,
because it's a ratio.
Exactly, yes, it's a ratio. So that means that we don't actually know the exact length. However, for this question, we can cheat a bit. Forget the x, never mind. Just put the number is good enough. We can answer the question. Cheat a bit. Don't need to put the x. Okay, so now let's figure out what is sine A minus cos A. Part 1. Part A, sorry. Sine of A minus cos of A. So use the rule. Whenever A is obtuse, can you remember? What will it be?
For cosine, it will be negative.
Cosine is negative, tangent is negative. Oh, maybe it's better if I just take a screenshot and place it at the side. Wait, copy, paste it here in a smaller version so you can look at it while I'm writing. Yes, you were saying? So sine A is
Sine A is
alpha.
Yeah.
But positive. Then how about minus cos A? There's a minus, you copy down first, but there's a cos A. What do you do with it?
Minus cosine alpha.
Become a minus cosine alpha. Minus and minus, put bracket. It becomes a plus. Good. So sine alpha plus cos alpha. What's sine alpha?
Sine alpha is 5/13.
Plus? What's cosine alpha?
13.
Exactly, that's it. Then just 17/13 done. Okay. So the trick here is you must make obtuse angle into acute angle. Obtuse angle into acute angle. Can? Okay, part B. Let's go. So now this one, you have to I have to introduce a few more rules before I can talk about this one. So first thing, let's see what is the sine, cosine, and tangent of a negative angle. This one, I don't want to explain why. I will just use the formula. I call this the negative angle identities. You will learn more in detail in AMAX. Now I'm still going through the EMAX paper, but you are supposed to know this already from EMAX. Sine of negative theta and tangent of negative theta will be negative sine of the original theta without the minus. You can sort of factor out the minus. However, for cosine it's special, it's the same, just cosine theta. Here is an invisible plus sign. Okay? Okay, using this, we can solve the question already. So let me just copy down the diagram again. Copy down here, because my iPad not enough space. Just put it here. Maybe I'll also bring this down. Okay, so what's the question asking? We want to find cosine of 180 degrees minus A plus tangent of A minus 90 degrees. This one you have to be a bit tricky. This question is quite tricky. 180 degrees minus A, you have to look back at the diagram. What angle is it actually?
Alpha.
180 minus. It's alpha, so it's actually cosine alpha, right? Correct?
Yeah.
Then plus tangent of, what is A minus 90?
A minus 90 is is 90 minus alpha.
Not really. Not really. If you're using the negative angle identity here, let's try using this. What would it be? You can rewrite a minus 90 degrees as negative times negative 1. Okay, just factor out negative. Negative 90 degrees minus a. So tangent of a minus 90 degrees is the same as tangent of negative 90 degrees minus a. Then because of this rule, when you got a minus in front of the angle, there's a minus in front of the angle. It's just that the angle here got two terms, 90 degrees minus a. You can take out the minus sign. Take out the minus sign. So it's actually equals to negative tangent of 90 degrees minus a. Is this part okay?
Okay.
And then 90 degrees minus a, what is this angle? Oh wait, actually, sorry. Did I make things too complicated? 90 degrees minus a might be negative angle already. Sorry. Let me try again. This part, the one. I think you need to draw a diagram. Yes, this makes more sense. Okay, you can do the following. You can chop off a 90 degrees from the A here. Then that means this angle here will be your A minus 90. Correct?
Mm-hmm.
Okay, good. Can you see a Z shape here? Can see?
Yeah.
Yes. So that means that this angle here must also be
A minus 90.
very good. Yes. Let me just highlight it. This is called alternate angles. Not sure if engineering course actually need to learn more about proofs. Proofs involving alternate angles, corresponding angles, interior angles, or all the angle properties of circle, like angle at center equals 2 times angle at circumference, that kind of thing, if you remember.
No, I don't.
Don't remember. It's from Emacs. These concepts I asked my friends around already for engineering. Technically, they don't really need this, but it is still in the Emacs syllabus. So later when we get there, then I'll ask you, do you want to learn or not?
Okay.
And engineering, actually, they never use this. But good to know. Maybe in physics, some special question. Yeah, so anyways, now that you identified this as A minus 90 and it's inside a right angle triangle, do you know how to find tangent? I actually don't need negative angle.
Yeah, sure.
Opposite relative to this angle.
12/5.
Yes, correct. Then cosine alpha?
Cosine alpha is just 12/13.
Yes. So 12/13 plus 12/5. Then can just use calculator. Plus 12/5. You get 216/65. Answer. Okay?
Okay.
Okay, good. Actually, in the future, we will learn about if we are continuing the lessons all the way out. Then cosine 180 degrees minus a. Actually, there's a formula we can use. It's called compound angle identities. It's in Emacs. You can actually expand it this way: cos a cos 180 degrees times cos a plus sine 180 degrees sine a. And in the future, you will learn how to evaluate cosine 180 degrees. You will encounter these kind of curves. This is called the cosine curve. And this is called the sine curve. Have you heard of it before? Have you seen it before?
No.
Yeah. So yeah, it's in the Emacs syllabus. Okay, actually it goes on forever. You just have to duplicate this. Many copies. You will learn more about this in the future. Cosine curve. Likewise for the sine curve. You just make many duplicates of this. Infinitely many. It just goes on forever, left and right. Okay? And in cosine of 180 degrees, 180 degrees is actually here. You just have to read off the curve. And you realize that it's -1. So this guy can be a -1. Likewise for the sine 180 degrees, You just have to look at the sine curve. Sorry, I forgot to label. You just have to read off 180 degrees, and it happens to be here. Here will be 180 degrees, and it happens that the y coordinate is 0, so you can replace this with a 0. Then what you will get is -1 times of cosine A plus 0 times of sine A, which is just 0, which is negative cos A. Okay? Does it make sense? Maybe not so useful for now. Maybe it doesn't really make sense, but in the future, it will make more sense. Okay, for now, forget it. Just draw that, just based on the diagram, it's good enough for Emacs questions. Can? Okay.
Okay.
Okay, good. Next question. Which is the next question you got wrong. They're all very well done. Which one wrong? 22C, variance one. 22C, standard deviation. Emacs, actually, we never test on probability and statistics. So this standard deviation formula, right, but you will need to use it in engineering in university. I asked my friends also about this, whether you need to know about standard deviation, and they said yes, yes. You need to know how to use the formula. Okay, so let me show you the formula. Just write it down. This is 22C. Standard deviation formula, SD, is actually just equal to square root, okay, of sum of, wait, let me think a little bit. X square over n minus bracket square of sum x over n. What is this funny symbol here? Sum.
Summation.
Summation. Yes. Just add up a bunch of terms. So let's do a quick example. Let's say you have index number n and then tn for a term. Let's say 1, 2, 3, 4. And then you got some data. You collected some data, like some science experiment. You measure the length of some quantity. Let's just call this L. Then 1.3, then 2.7, then 0.5, then 1.4. Okay, maybe I shouldn't use decimals. I'll just use whole numbers. Make it easy. 2, 3, 2, and 5. Okay. Then how do we find standard deviation over here? First, we need to figure out how what is this Ex over n. Ex over n is actually the mean. Okay, it's actually the mean. Did you know that? The mean.
No.
Mean, median, mode. I think you know, because you could do the previous two questions, part A and part C.
Or like mean is average, median is like the middle number, then mode is the most frequent number.
Correct. Yes. Okay, you got it. Yeah, you know. Most frequent. Okay. This is the formula for mean. Just add up all of the numbers, sum of x. Or maybe I should change the notation here. I should call this I and xi. So this 2 here is x1. This 3 here is x2. This 2 here is a x subscript 3. This 5 here is x4. Then sum x is actually, okay, I'm going a bit into A-level content already, but you can learn how to do this. It's x subscript I and I equals to 1 to n. Okay, and over here there's also some subscripts. It's sum of xi square. Then you sum it from I equals 1 to n. Okay, we'll see how to use this formula using this simple example. So let's see. Let's figure out what is the mean, x bar. It is sum of xi, I equals to 1 to n divided by n. What does that mean? It means I'm going to add, in this case, your n is what? The n is the last number, which is 4. Okay, this is my n. So I'm going to replace my n there with a 4. And what does that mean? It means I'm going to add x1 plus x2 plus x3 plus x4. Then I divide by the number of numbers 4, which is just a long-winded way of finding the average. But this is the formula way of writing it. This is the average. You already know how to do this, right?
Yeah.
Yep, okay, then just add 2 plus 3 plus 2 plus 5 divided by 4. I get a 3, 12 over 4. Okay, that's my x bar. Then next, I need to find out what is this sum of xi square, I equals to 1 to n divided by n. In this case, my n is 4, so I replace it with a 4, So let's see what is this. We will get, this is really just x1 square plus x2 square plus x3 square plus x4 square. So I'm basically replacing the subscript I here with a 1, with a 2, with a 3, with a 4. That's why it says 1 and 4. Okay? Yeah, then you divide by the n, which is a 4. Okay, can. Let's see what is this. It will be 2 square plus 3 square plus 2 square plus 5 square divided by number of numbers 4. Let's check with a calculator. What do we get? 42 over 4. 10.5. Okay. Can?
Okay.
Can. Then now we use the formula. What is standard deviation? SD. It's just square root of, then you substitute in the formula. Over here, it's 10.5. Correct? So I put in 10.5.
Yeah.
Please stop me if you don't understand.
Okay.
Then minus away, bracket power 2. Bracket power 2. What's inside the bracket? What's inside the bracket? It's actually x bar here. This guy here, which is 3. So put down 3. Okay? Then you just use the formula, square root 10.5 minus 3 square. This is, let me check.
1.2.
Square root 1.5, which is, let's see, 1.2247. Yeah, then you just have to round off 3SF. Okay?
Okay.
Actually, there are 2 formulas to standard deviation. The one that I gave you is the easier version. There is a more difficult version, which looks something like this. No space. Wait. If I am not mistaken, let me think a little bit. Sum of xi minus away x bar. You take the square, and then you take the sum, you divide by n. Is this formula? This is the other formula. X bar. Okay, maybe I'll just simplify this as x bar. I think it's easier. And then I'll just write down the formula for x bar, where x bar equals sum of xi, I equals to 1 to n, divide by n. Average. Okay, this is the other formula. It also works. Do you want me to verify this formula as well with the example?
Sure.
Okay, we should get the same answer. Let's just use the formula. Okay. Can. So standard deviation, the other formula, this is method 2, is also this formula. So let's just check with the data. So we already figured out what's x bar over here, right? Which is 3. So that means if I sub in the formula, I'll get square root sum from I equals 1 to 4 of xi minus away the average, which is x bar 3. Then you square it, divide by n. Sorry, divide by 4. Simplifying a bit more, what does that mean? It means we take x1, we minus away 3, then we square it. Plus, we take x2, we minus away 3, we square it. Plus, we take x3. And then the last one, x4. Can see the pattern, right?
Yeah.
And then you take the square root of the entire thing. That's the standard deviation. Okay, then what is x1, what's x2, what's x3, what's x4? You look back at the example. Let me just copy and paste it down so I can have an easier time. Yeah, so I'll just sub in. So take the square root of 2 minus 3 squared plus 3 minus 3 squared plus 2 minus 3 squared plus 5 minus 3 squared, all divided by 4. Let's check. let's see. Yep, should be the same answer. Yeah. Let me know when you're convinced.
Oh, I'm convinced.
Okay, or after you finish typing, you should try and type it. That is the manual way. That's the manual way using formula. You will need to do this in engineering course.
Yeah.
Can or? Okay, good.
Yeah.
So you have learned how to use both versions already. Then there is actually an even more difficult version where there is frequency involved. The formula that you get to see in O levels is actually this one. Let me write it out. Fx over n. Oops, forgot a square. Minus way sum fx over n bracket squared. This is the formula that's given in O levels. Okay, there's some formula list if you remember. There's a little f over here. It's representing the frequency. So in this example I give you, right, the frequency is all one. You see, this one is just one. This one is just one time. This one one time. This one one time. They could have presented the data in grouped format. So like for example here 2 appears 2 times. So they will draw a table like this. Frequency and the actual data. How do I describe this? Let's say xi. Then if they say 2 and 2, it means that the 2 here appears 2 times. If they put 3 and then they put a 5, it means that a 5 appears 3 times. Does that make sense?
Okay. Yeah.
But I think I don't go through that for now. I don't go through that for now. A bit too involved. So for the standard deviation of this set of 11 numbers, right? Your x and y you found it is correct already. Then you just have to use the formula to go and find standard deviation. Do you want me to go through?
I think it's okay. Because
All 11 numbers. Yeah, I gave you one simple example. Maybe you try again. This time with all 11 numbers. Yeah, you see it's quite long-winded. Just 4 numbers is already a lot of steps. Oh yeah, right. There's also the calculator method. Do you know how to use the scientific calculator to help you find?
No.
Okay, I show you. I think this is method 3. Some calculator. Let me see how I can share my screen. Okay. Give me a moment. New posture. Change to my camera. Resume. Wow, you can see my fingers. Okay. So this is the scientific calculator. Okay. So
okay.
Yeah, then actually there is a way for you to find the standard deviation. You just need to go to step mode. Okay, press mode here and press number 2. And all these, right? Just choose one variable. One variable is okay. Then let me just check my data again. I forgot what's the numbers I had. The numbers I had were 2, 3, 2, 5. Okay. 2, 3, 2, and 5. So I just have to key in 2, enter, 3, enter, 2, enter, 5, enter. Then I press AC. Then you notice a 0 here. You notice a STAT here. That's that mode. So now you have to calculate the standard deviation. All you need to do actually, right, is just shift stat here. Can you see a yellow color button? You just have to press shift to activate and you press that button. You see all these different things, right? Just press number 4 for variance. For variable, sorry. Okay. I think on different models of calculator, it will be different. For me, it's number 4 VAR variance or variable. You see all these? N, X bar, sigma X, that's a Greek letter sigma, and an SX. The correct option should be number 3. Okay, for standard deviation.
Okay.
Then press number 3 and what do you get? Oh, you got the answer straight away. So we could have just used a calculator.
Okay.
But I just show you the formula way. So now you know how to find standard deviation, 3 different ways. Yeah. Actually, yeah, okay, I don't talk about sample standard deviation, never mind. Refer to video. Okay. Ken,
Sorry.
this is recorded. Yeah, you can refer back. Okay, next question that you got wrong. Let's see. Which one was it? Question 23B. Okay, not such a big deal. Question 23B, it's just your reasoning a bit fuzzy. When you have proof questions that that require explanation, I think the diagram was something like this. 2 equilateral triangles. This length here, this length here, this length here, then this length here. They were asking, oh sorry, no. This length here and this length here. They're asking you to prove that this green one is the same as this green one, right?
Mm-hmm.
Some sort of pentagon. Then my only fault with your argument is that you should have started off by saying that this length here is the same as this length here because all sides of a regular polygon are equal in length. Okay, so you slowly link from this length to this middle length. And then this length here is the same as this length here because we have an equilateral triangle. So you link this length here to this third length here. So you must slowly reason. First length to second length to third length. You just jump straight to this is equilateral triangle, therefore these two are equal. So there's a gap in the reason. Okay, yeah, that's all, but nothing serious. Okay, and let's see what's the next question you got wrong. I think that's all, right? Did I miss anything? Question 19. What's question 19? Let's see. Question 19 is constructing a perpendicular bisector. Okay, don't need for Amex. You don't need it for Amex. In fact, do you still want me to demonstrate?
No.
No. Okay, can good. Okay, then now let's focus on paper 2. I want you to zoom in on those. What were the questions I specified? I checked yesterday. Question 2, 4, 6, and 7. Okay, let's focus on those questions. The rest are honestly not tested in Amex.
Okay.
Or not. Actually, you already understand. There's an algebra question, but not that important. Okay, let's start with question 2. Let me just sorry, give me a moment. I need to download the paper. Sorry. Let me find the paper first. Okay. Yeah, where is the file? Paper 2, question 2, right?
Mm-hmm. I forget how to prove congruent.
Prove congruent. Okay, Ken, I'll just do it on this paper. So let's just go through. So first thing you must remember for proving, right, is for similar triangles, SSS, SAS, and AA. Okay?
Yeah.
This is similar triangles. Then for congruent triangles, it's SSS, SAS, AAS, and RHS. This A here must be included angle. Do you know what included means? Sandwich. Meaning, here's a side number 1. Here's a side number 2. Then there are 3 angles. Which angle must it be?
The one in between. Yeah.
Exactly. Yes.
Okay.
You remember? Yes, included. Okay. Then yeah, you just need to use these rules, then you can prove congruent triangles. Let's just see the question. And you need to remember all the angle properties. I'll just name it along the way. I'll name it along the way. So let's read the question. The diagram shows two circles with equal radii. So P, T, and R are points on the circle with center Q. Okay, so center is, let me just highlight the center. Center Q, and P, T, and R are the corners, or highlight in yellow. Q, T, S, and U, Q, T, S, and U are points on the circle with center R. Okay, so they intersect together. So this is another center, center R. Okay. Q, T, S, and U are points on the circle with center R. Okay. P, Q, R, S is also a straight line. So this fella is a straight line. Okay. Then show that the triangles PTR, where's PTR? Let me see. Over here. And UQT, where's UQT? UQT is here. You want to show that they are congruent. Let me think a bit. This might. Okay, I can see. All right, so what we can do, usually for proving congruent triangles or similar triangles, what I'll do is I will just copy down the orientation, copy down two copies of the same triangle, but with different labels. So in this case, I can see the purple color triangle, which is PTR. Then I'm just going to duplicate the exact same diagram. Duplicate. Okay, duplicate it. And then I just relabel the sites. So instead of PTR, it's going to be what? UQT, right? Must be in the same orientation. Then I can tell straight away that PR, this length here, is the diameter, right?
Yeah, so it's equal UT.
So it's equal to UT because it's also, they have the same, yeah, it's also another diameter. So they are equal already. You can just put a tick mark like this. What else? Let's see. PRT. Okay, this angle here. Let's just label it here. Maybe I'll just draw a single line like this. Can you see that it is an angle that starts from P and T and then it moves towards R? Right. So that means we can also reinterpret it as this circle starting from point Q and T, you move towards R. Right? Then what can you tell? If you have a point Q or point T, you move towards a point in the center. And then you have a point Q and a point T, you move towards a point at the circumference. What's the angle here? It must be half of it. So let's say that this angle here was 2 theta, then this will be theta. Right? Okay.
Yeah.
Good. Then is there anything else we can tell? Okay, I think maybe that's not so useful.
Angle in semicircle.
Angle in semicircle because we got diameter, right? So
Yeah.
here is a diameter. That means this angle here is 90 degrees. Any other 90 degrees? Here's another diameter, right? So here is also 90. Let's just label it on this diagram here. Angle PTR 90, angle PQT 90. Oh, so let's take a look. 90 degrees. Which which formula can we use? SSS, SAS, AAS, and RHS. Must be
R.
The one involving right angle.
Yeah.
Must be R. R means right angle. H stands for hypotenuse, then S stands for side. Let's check what information we have. We got hypotenuse, right? We also got 90 degrees. So all we need now is one more side. We just need to prove one of the sides are the same. Equal in length. Or we could also use AAS. Find two
Oh.
angles that are the same.
RT equals to DQ cos radius.
Right, correct. Yes, they're the radius. This is the center going towards a point on circumference. Point going towards circumference. Center point going towards circumference. So they are both radius and they are equal. Okay. Yeah, then we solved it already. RHS. We got a right angle, we got a hypotenuse, we got a side. Right angle, hypotenuse, and side. Okay, so let's write it up nicely. So we can say PR is equal to UT because diameter of both circles with equal radius. Then we can also say angle PTR is equals to 90 degrees because of right angle in semicircle, which is also equal to angle, let's see, UQT, right? And we also have the last length TR equals to QT. This is because they are both the radius of circle. And they are given to be equal. This was given. Right? They gave it to us. Equal radii. Okay, then you can say by RHS, triangle PTR is congruent to triangle UQT. Okay, good. Thanks. Any questions?
No question.
Okay, next question. Name another triangle that's congruent to PTR. Let's see. So PTR is which one? Maybe I'll just remove the highlight. It's a bit messy. This triangle. Can you see another congruent triangle?
UQS.
Yeah, UQS. There's another 90 degrees here. So let's just try to be a bit more careful. Let me see. PTR and okay, you must follow the orientation carefully.
QUS.
QUS or is it SUQ? Let's see. Yeah, it's QUS. Correct. Looks correct. How do we know for sure? Let me see. We know this must be a 90 degrees because of the right angle. How about this angle here? It's the same as which angle? Is it the same as this angle or that angle? Left or
Angle
right?
UQS is the same as DPR.
Same as TPR. How do you know for sure?
How do I know?
It looks correct. But well, I'm scared to conclude immediately. Let me see. QS. Let me see if there's a hint. Okay. I think that's not the requirement of the question. Right? They didn't ask us to prove it. But if you want to prove, I can see that. Let me just erase the details first. These are not important. Can you see an equilateral triangle here?
Oh, okay.
You can prove that it's an equilateral triangle because these are all radius, and radius, so they must be equal. So here is 60 degrees. We also know that this is a 90 degrees, right? So what does it mean about this blue angle? 30,
30.
yes. Let me just use blue color, 30 degrees. Then let's see, over here we got a 60, sorry, we also got another 60 degrees because of equilateral triangle. We also got another 90 degrees because of right angle in semicircle. Then what do we know about this angle here? This one.
30.
30, 90 minus 60, yes. Then if
And
you
then
look carefully,
isosceles triangle.
oh, where's the isosceles triangle? Right. Two radiuses here.
Yeah, radius.
Therefore, this is
30.
also 30. Then
Okay.
confirm, they must be the same. So yes, your answer originally was correct. Once you get two angles the same, confirm must be the correct orientation. So QUS. Yes. Okay.
Nice.
Good. Okay, so explain why TQ is parallel to SU. TQ, where is TQ? Here. Where is SU? Here. Okay, this one you need to know the ZFC rule. This one of my students taught me this. ZFC. Do you know what is ZFC?
Or alternate what? Z is alternate angle. I forgot what F is.
F is this one. These two angles, if you just shift it down, it's the same. Like for example, like this angle here, you shift it down, it's the same. So they correspond to each other.
Corresponding angles. Okay.
Angles. Then the last one is so ugly. We try again. A C shape, parallel. This angle and that angle.
Add up 180. Yes. Okay. What is it called?
Interior angles.
Okay, interior angle.
Yeah, you know this. So you just need to use either one of this to prove that you have parallel lines. Let me just highlight the parallel lines. Parallel. So I think you can see. You get that. C. There's a 90 degrees here and here. Just need to add them together, equal 180, then just quote interior angles. The C. Okay, then therefore they're parallel. That's all.
Okay.
Okay, let me just write it up. So angle T. Sorry, let me just take a screenshot of this diagram. So I don't need to scroll up and down. Okay, let me just shrink it down and move it here. So I can say the angle TQU equals to 90 degrees because of right angle in semicircle. Oops, right angle in semicircle. A diameter. And we also know the angle QUS 90 degrees, same reason. Then therefore we can say that let me see. Angle TQU plus angle QUS is 90 plus 90, which is 180 degrees. Then we can just quote by interior angles. The two lines are parallel. Okay. Can Okay, next one, part 4. Stating the reasons clearly, find the value of angle UQR. Okay, let's look back at the diagram again. Where is angle UQR? Oh, we found it already. Right?
Yeah.
Okay, so do you need me to explain further?
No, it's okay.
It's okay, Can. Good. UQR, just 90 minus 60. Okay, can. Let me just write it down. Not very clear, but I think you get it. Okay. Next one. Question 3, I'm gonna skip. Okay. Skip. Question 4. Let's see. This one is mensuration. Must remember the formulas. So let's read the question. Diagram below shows an open cylindrical container with a diameter of 12 cm and height 4 cm. Assuming the thickness of the container is negligible, calculate the area of material needed to make one container, giving your answer correct to the nearest square centimeter. When they say open, they mean open on both sides, I think. So there's no lid and there's no base. So it's like this part here and that part there at the bottom, they are missing. They don't exist. So you just need the curved surface area. Okay. Let me think. Container. Oh, wait. Sorry. No. The base must be closed. The base must be closed. If not, it can't contain anything. Right? So open here just means the no lid. There's no lid. So how do you find the area? You have to imagine a bit. This part here is the curved part, right? Can you see? Can you visualize?
Yeah.
Then if you cut it over here, like let's say you cut this piece of paper and then you unroll it, what will you get? You'll actually get a rectangle. And you have a circle below it, right?
Mm-hmm.
This circle is the red one. Then can you tell me what's the length and breadth of this rectangle?
Breadth would be 4.
Yes. The length?
Length would be circumference.
Yes, very good. It is the circumference, this part here of the circle. So in that case, just remember the formula 2 pi r.
Pi d.
Pi d also can. Same thing. Here they already gave you d, right? 12 cm. So you can just take pi times 12 pi. Okay?
Okay.
Good. Okay, then what about the radius of this circle? The diameter. So that means you find the radius of 6. Okay, this one. You got A1 for Emacs. I think this is very easy for you. Good. Don't need to explain until I have more time to go through more content. Okay, so radius here is 6, right? Then that means I can find the area straight away. Pi r squared. How about the area of the rectangle? Length times breadth. 12 pi times 4. Then to get total area, just add them together. Does that make sense?
Yeah.
Okay, for Emacs, you need to learn how to find in exact form. So what I'm going to do now is I'm going to ignore the question. Nearest square centimeter. No, I'll give exact form, meaning you leave your answer in terms of pi. So what is 12 pi times 4? You can leave the pi alone, then just multiply 12 with 4. You get 48. Correct? Then how about 6 square times pi? 6 square is 36, so 36 pi.
Yeah.
Then got 48 pi plus 36 pi, just add them together. 48 plus 36, you get 84. Answer, cm square. Okay? Can? You need to know this. You need to learn about differentiation integration. Have you learned it already?
So wait, say again.
Differentiation and integration.
Yeah, no, I haven't.
Haven't? Okay, that's what you're supposed to know from Emacs, the main block, the main thing that you need for engineering. And this is the kind of question that they will test you on. So instead of giving you like 4 cm, in the future, you will see, you'll give you a HCM. Then how do you find the formula now? Just replace everywhere that you see a 4 with H. So for example, this one will be 3H, this one will become 12H, 12 pi H, so on and so forth, for example. But never mind, let's just remove that. Let's just stick to the easy question for now. In the future, then you'll see in the future. Okay? Can?
Okay.
Okay, next. Good. Hemispherical pen. Okay, give you formula first. Volume of a sphere. This is subscript notation. V, then I subscript, I write down the description, V sphere. This will be equals to what? 4/3 pi r cube. Okay, 4/3 pi r cube. Then what about hemisphere? Hemi just means half. Then just divide by 2, so it becomes 2/3 pi r cube. That's for volume. But there's also the curved surface area. Okay, curved surface area of a sphere. What would it be? 4 pi r squared. Okay. Then if it's a hemisphere, just divide by 2.
Okay.
Yeah. You should try to keep this in your head. If not, you just refer to formula list. Then hemispherical pen, they tell you is completely filled with 13 liters of water, of soup. As many containers as possible are completely filled with the soup from the pen. Calculate the number of containers which are filled. So the container is referring to the previous container. So that means we need to calculate volume of container first from part A. What would it be? V equals? How to find volume of this this cylinder?
Pi 36 pi times 4.
36 pi. Correct. Oh, you're talking about this one. Yes. Pi r square times 4. Okay, so basically, right, remember for the volume of pips, right, you always remember it's always V equal base area times times depth. Okay, BA means base area. But for pyramid, pyramid is a different case. You need to have extra 1/3 times base area times depth or height. Okay. Yeah. So just simplify this. 36 times 4 is what? 36 times 4 is 144 pi. Okay. I'll just copy down this working. Bring it down. cm square. Let me check. Yeah, cm square. Sorry. Then now you want to find the volume of this hemisphere, or let's just call it the pen. What would it be? Formula 1, 2, 3, or 4?
Hemisphere.
Number 2, because it's a hemisphere. So you use 2/3 pi times r cubed. What's r in this case?
What is R?
We don't know. Right?
Yeah.
We don't know. So that's why actually this, sorry, I realized that it's wrong. No, we cannot find out the volume using that formula. But what we do know is
13.
10 liters of soup. Yeah. So we don't really need to know. So we already know what is the volume of a pen or volume of soup. Volume of soup. It's just 13 liters. Then just divide.
Yeah.
Number of containers will be 13 divide 13. Sorry. I will assume that the density of the soup is just sorry. Oh wait, no. Forget density. 13 liters is by definition the same as 13 1 liter is the same as 1000 cm cube by definition. Yeah, don't need that density. So this is just 13,000. So you just need to take 13,000 divided by 144 pi. Let's just leave it in exact terms. 13,000 divided by 144, I get 1625 over 18 multiplied by, 1625 over 18 pi. The pi must be a denominator. This is the exact form, but since they ask for a number of containers, we have to see 1625 over 18 times pi. I get 28.7. Do you round up or down?
Round down.
Round down, yes. Because you have 0.7, 0.73, whatever. That's actually just, let me calculate this. That's actually a remainder. We will get a remainder of 333.098 cm cube, approximately. Do you know how I calculated it? How I calculated this?
Oh.
I just took 28. I multiply by the volume of each container, 144 pi. Then I subtract away from the total, 13,000. Oops, not here, 13,000. Right? That's a remainder, which is less than 144 pi. 144 pi is around 452. Yeah, so not enough to fill up one full container. 333, you get a remainder. So just 28. Okay. Do you need me to explain how I got this?
No, it's okay.
Okay, let's move on. Okay, 4B. Calculate the volume of soup which is left in the pan. Oh wait, that was the that was the question they asked. Okay, I'll just explain. So we just figure out the volume of total volume in all 28 containers. This will be equal to 28 multiplied by, what was the volume? 144 pi. Yeah, no choice, have to explain. This is in the question. 4032 pi cm cube. So that means that the remainder will be, which is left. The remainder is the amount that's left. You just take the total, which is 13,000, minus away 4032 pi. Does that make sense?
Yeah.
Okay, which is 333. 3SF. Okay, this is good enough. cm cube. Oops. Okay, can next be part 3. You calculate the radius of the hemispherical pen, giving your answer correct to the nearest millimeter. Okay, so 1 dp. Because 10 mm is the same as 1 cm. So it's basically asking you to round off to 1 dp. Okay. Okay, so how? Let's just use the formula that we were trying to use just now. Remember this formula? Over here? This one? Mic test, can you hear?
Yeah.
Oh, sorry, can. Yeah, so we just have to use this formula, 2/3 pi r cube. Okay, so let's just copy down this formula, 2/3 pi r cube. So we know that the volume of the pen of of all the soup that's filled up the container is 13,000 cm cube. So you can just equate it to 13,000, then solve for R. Okay, let's see how we can do that. So just divide by 2/3 pi. So 13,000 on top, divided by 2/3 pi. Okay, simplify, you can actually bring this 3 on top. So you get 13,000 times 3 over 2 pi. You don't need to do this. Actually, if you know how to type in a calculator, you can just get this answer straight away. But let's try to get an exact answer. So I actually can simplify this as 19,500 over pi. And how do you solve for R? Do you remember what's the opposite of cube?
Cube root.
Yes, correct. So cube root. Do you need me to demonstrate on a calculator? Where is the cube root?
No, it's okay.
Don't need. Okay, I got some students who don't know where is it. So that is the radius. Do you need plus minus?
No.
Why don't need? I thought always need plus minus.
That's for square root.
Very good. Yes. Now some students they confuse between the square root and cube root. Square root need plus minus, but cube root you always only have one unique solution. So just positive. Yeah. Can part C. That's 1 cm. Later you can run off to 3SF on your own. I'm sure you know how to do that. Okay, beta has 2 different containers which are geometrically similar to each other. The height of the containers are in the ratio of 2:3. Write down the ratio of the volumes of soup these containers hold when full. So why is the question so vague? Why they never give us the dimensions of the container? It's because they are assuming that you memorized this formula before already. V1 over V2 is equal to L1 over L2, bracket, power what? 2 or 3? Volume.
Wait, let me. What? Wait, what's the unit for volume again?
cm cube.
cm cube.
Meter cube. Km cube.
Then liter is what? Liter is just
1 liter is just
1,000
cm
ml.
cube.
Yeah, or cm cube.
ml. So over here, it's just a standard formula. Cube. Do you remember this?
Yeah.
Okay. Sorry, I'm eating something. Okay. So you want to write down the ratio of the volume, right? You actually just need to take the ratio of 2 proportional lengths, and they gave you 2:3. So you just put down 2 over 3. Bracket cube. That's all.
Okay.
Yeah, that's all already. Why is that? Let's see, 8/27. Okay.
Okay.
What's the next question I ask you to do? Question 6. Okay, scroll. Okay, find question 6 first. Oh yeah, here I ask you to skip question 5, right? Because it actually involves bearings, sine rule, and cosine rule. Do you remember those?
No.
No, okay. You actually don't really need it for AMAX, but you might need it for, not mine, you definitely need it for engineering. So do you want me to go through? Are you planning on doing engineering?
I mean, okay, yeah, you can go through.
Okay, I'll go through. Why not? Sorry, let me finish chewing this. Okay, Ken. So this is question 5. You have a cliff, vertical cliff. You must think 3D a bit. Then this QTP, right, is the plane on the floor. Then this rectangle here is vertical. And you can see that there's a right angle triangle here. Can you visualize? You look at it. If you have an eyeball, you're staring at it from the side, you'll see a 90 degrees here.
Okay.
Right? Okay, good. Let's do the question. So the rectangle PQRS, it represents a vertical cliff face. Foot of the cliff PQ over here runs from east to west and is at sea level. A ship is in the sea at point T. Okay, this is also this is the sea, this is the sea. The sea. And angle QPT is 75 degrees, angle PDQ is 63 degrees, and PQ is 45 meters. So the units are in meters. Find, not cm, find the bearing of T from Q. So bearing, you must remember the notation. When they say from Q, that's when you must draw something called the northing. Remember?
Oh, yeah.
Northing. So we must start from let's see. They already told you that PQ runs from east to west. So this is east, this is west. Right? That means west north. North is somewhere here. But take note that we are on a different plane already. So I'm going to draw a separate diagram like this. Whoops. Then I'm going to draw a northing here at point Q. Okay, call it N1. Then you want to rotate clockwise or anti-clockwise from the northing? I'll just tell you, clockwise. Okay. Must this one memorize on, no choice.
Okay.
Yeah, then bearing of T from Q. So you start from point Q, which is over here, and then you go towards point T, or at least, or more like the line connecting point T to Q. So you turn clockwise like this, do you reach here? Do you notice that there's a 90 degrees here?
Yeah.
Okay, good. So you need to add 90 degrees to the extra angle over here. So the goal here is to find out what is this angle here, right? Can you find out what's the angle? You got 3 angles in a triangle, 63, 75, and the last one. So how do you find the last
180 minus the...
Exactly.
Yeah.
Minus the other 2, right? Okay, good.
Yeah.
So that's all the working you need. So that's angle PQT, huh? Yeah, just type in a calculator, 180 minus 75 minus 63. If you want to give a reason, it will be sum of all interior angles of triangle are supplementary. What's supplementary? It's just a technical word to say adds
80,
up to 90.
180. Oh, okay.
Yeah, because it's shorter to write. Supplementary adds up to 180 degrees. You want to save time, then you write the shorter one. Yeah, so 42 degrees. Then after that, the bearings will just be bearings from, of T from Q. It will just be 90 degrees plus 42 degrees, 132 degrees. Take note, for the bearings, right? If you got two digits, like for example, 23 degrees, this is wrong. You have to say 0, 2, 3. Must have 3 digits.
Okay.
Right?
Yeah, I remember.
Okay, good.
Or not
okay,
really, but like, yeah.
Okay, just must have 3 digits. Okay, that's for part A.
Yeah.
Let's move on. So part B, show that QT is 48.8 meters, correct to 3SF. QT, let's look back at the diagram. Where is QT? Over here. So do you remember something called the sine rule?
Is like sine B over B equals to sine A over A or something like that.
Correct. Exactly. That's exactly right. I mean, not exactly A, but length A, length A.
Yeah.
B. Okay, so how do we show that the QT is a certain length? I will be more strategic and I will flip the fraction around. So it's B over sine B and A over sine A. I'll start by using this formula. And then my top left-hand corner here will be my 48.8. Or rather, not 48.8, the QT. We don't know it's 48.8 yet. So what's B? Angle B.
QRT.
So let's figure out what's this angle opposite of QT, right? Remember, it must be opposite. Must draw a pair like this.
75.
So 75 degrees. Yes, correct. Good. Remember. Then how about the length A and the length and the angle A?
45 and then 63.
Okay, good. Yeah, that's it. Right, just
Okay.
you know use sine rule. So you remember already. Okay, slowly remembering. Then you just have to bring the sine 75 over, and QT equals to 45 over sine of 63 degrees multiplied by sine 75 degrees. Type in the calculator. Make sure your calculator is in what mode? Degree mode. Okay. If you use radian mode, die. 48.783. Then you'll get 3SF 48.8 meters. Okay.
Okay.
Okay, good. So that is QT. Let's move on to part C. Calculate the shortest distance from the ship to the cliff. It's usually referring to perpendicular distance. From the ship to the cliff. Let's look back at the diagram. Ship to the cliff, shortest distance. Where's my ship? Over here. Where's my cliff? Over here. Shortest distance must be here. Can you see? This is the shortest distance. It's like when you're trying to jaywalk. You got jaywalk. This is opposite side of the road. You want to cross over to the other side. Would you walk diagonally like this? Or would you walk straight across?
Straight across.
Straight across, right? Because it is perpendicular. Okay, so same thing over here. The ship is traveling to that line. You just have to find a perpendicular line. Perpendicular line. So how can you find out the length of this what do you call it? The vertical line. You need to see the trick. Can you see a hidden right angled triangle here?
Yeah, sure.
We know what is the blue angle, right? What was it again now? 42, right? Degrees. Yeah. We know the length here is 48.8. Let me just redraw that triangle again. 48.8, 42 degrees. This is the question mark. Can you solve? Can you figure out a good Picasso value ratio that will help us to find the question mark? Oh, you're writing something? Okay.
Okay, you need O and you have H, so you sign.
Exactly, yes, you use sign. Okay, so sorry, I wasn't paying attention to what you were writing out. Do you write anything important that you want me to see?
No, I wasn't.
Okay, can yeah, and then I'll just copy down the diagram below so I have more space to write. Yeah, so yes, you just need to figure out this. No, let's just call this L, L for length. So yes, you just need to take the sine of 42 degrees. It will be opposite L over hypotenuse 48.8. Or maybe let's just use the more accurate version, 0.783 from the previous part. Then just solve for L. Can you see that it's just multiplying the 48.783 over times over?
Yeah.
Can, right? Okay, then just multiply 48.783 times sine 42. You can also use the most accurate answer on your calculator. But I don't think it's necessary because you're rounding off to 3SF anyways. Meters. Okay, that's all. Can?
Yeah.
This part, the algebra, are you okay? Are you okay? Do you need more elaboration? Can I understand?
Yeah.
Cannot? Okay, good. Next. Let's move on. Oh, my battery is. Sorry, let me get my charger. Okay, done. Yeah, so not done yet. Okay, question 5. Let's move on. So angle of depression of the ship when viewed from R is 16 degrees. Find the height of the cliff. Okay, I'm so sorry. I think I spent a bit too much time. I don't have time to go through quadratic inequalities. We'll go through that next lesson. Is that okay?
Yeah, that's okay.
Next lesson now. Or you want to cut and go to quadratic inequalities? The Amex content.
Actually, I think that's better. Then like I can do like homework.
Yeah, that's why.
Yeah.
Okay, I'm gonna cut.
Yeah. Sure.
Okay, I'm gonna go to quadratic inequalities. Yes, makes more sense. Let me start a new worksheet. No, not this one. Okay, so quadratic inequalities. You downloaded the worksheet already?
Yeah.
Yeah, so we're gonna go through that. So basically, quadratic inequalities, is just combining inequalities. You've previously done, like for example, which is the question I remember I sent you before. Let me find it first. In the e-math paper, I see that you know how to solve quadratic inequalities. You know you're supposed to split it into two. Let me find that question. Question 14a, right? Question 14a. If you remember that question.
Okay.
That kind of inequalities, right? What do you notice about the x, the highest power?
What do I notice about the x?
It's just x, right? Is that x squared? Don't
No.
have. No, don't have. So it's just x, which is what we call linear. Linear means its highest power is 1 only. There's no power 2. Okay, but now we are upgrading to quadratic, meaning that we will have x power 2. This is quadratic. Quadratic inequality is not so easy to solve. You need some tricks. You need to learn. That's why it's only in Amex. And let's just begin by solving questions, then you'll see straight away. It's really the same as solving quadratic equations, but you just have an inequality this time. No more equal sign. Yeah. So let me just bring out the. Sorry, wait. Give me a moment. I need to find the file. Okay, let's go. So question 1. Let me label section 1 and question 1. I'll try to see. Let me see. I think I can cover 3 sections. I think the 20 minutes is enough. But because I think your foundation is quite strong. I think you can follow. Let's go. Question 1. Find the discriminant of this quadratic. 5x squared minus 4x minus 11. Let's see. If you remember, x equals to negative b plus or minus square root of b squared minus 4ac all over 2a. Remember this formula?
Yeah.
Now you must memorize it, especially this part here. There's a special name we call it. We give it. It's called the discriminant. Can you remember? Discriminant b squared minus 4ac.
Yeah.
Okay. Good. You found it already. Yes. So negative 4 squared minus 4 times 5 times negative 11. What's the answer?
Calculator.
Yeah, yeah. Okay, I'll calculate it for you. 236. Can?
Okay, nice.
Can? Okay, good. Then let's move on to the next one. So now question 2. Question 2, we want to look at 3x squared minus 108 less than or equal to 0. If this was just equal to 0, you know how to solve, right? How would you solve it? Maybe you can factor out 3 first. So x squared minus 108 divided by 3, what is it? 36. Then you can divide by 3 on both sides. Divide by 3, you'll just get 0. 3 cancel off, x squared minus 36. Correct?
Mm-hmm.
Then
6 or minus 6.
Yes. So x minus 6 or x plus 6, right? You can factorize.
Yeah.
Right? Because 36 is 6 squared. Then you can just solve for x. Blah, blah, blah. Okay, you know how to solve. Now, we are just changing the equal sign into an inequality. Okay, level 1. This is section 1, the easiest one. It's exactly the same. If you know how to solve equation, you also know how to solve inequality. Just change the symbol. Let me show you. Factor out the 3. Less than equal 0. Not just equal, it's less than or equal. Then divide by 3 on both sides. But this time you have to be careful. What happens when you divide by a positive? Do you need to flip the sign?
I wouldn't think so. I'm
No,
not sure.
don't need. Whenever, okay, just remember this. Divide or multiply by a negative, flip direction of inequality. All other cases, you just remain the same. Don't need to flip the direction. So just copy and paste.
Okay, can.
Then I think you can see the pattern. Just factorize again. I don't need to explain this, right? I think you know how to do this. Factorizing. You know how to use the calculator to reverse and find out the roots, right?
Okay, say again.
The calculator trick. Use the calculator mode 22. Mode 32. Or mode 3, what is it? Mode 3. Right?
To do what?
To find the roots of the to factorize. Do you know how to use the calculator to help you to factorize?
No.
You don't know? Okay. I demonstrate. Wait,
I think I don't know.
x squared minus 36. Let me show you. Okay, back. I'm not sure if your calculator model is the same, but let's say we got 1x squared minus 36. So what is my A, what's my B, what's my C? You know this?
Yeah.
Press the
Your
mode
A is,
and 3 for
your A
equation.
is 1, then your B is 0, then your C is 36.
Yeah, exactly. So 1, then 0, then negative 36. Negative 36.
Oh, yeah.
Not just 36. Then equal. Then equal. What do you get? They'll solve it for you. 6, negative 6.
Okay.
Right? If they give you, okay, let me just change my screen again. So if they gave you x equals to 6 and x equal minus 6 as the answer, you have to reverse engineer, bring the 6 over. Then you get x minus 6 equals 0. Reverse engineer, minus 6 bring over, become x plus 6 equal to 0.
Yeah.
Then there's my two factors. You know this trick or not?
Yeah.
Oh, you know this, let me give another example. If they give you x equal to 2 over 3, or x equal to 1, I don't know, like let's say 5 over 7.
3x minus 2 or
yes,
7x minus 5 equals 0.
Okay, good. You remember. Okay. Then those are the two factors. Exactly. That's what I was talking about. Good. Okay. Then now, this is the difficult part. This is the new part. This is the only new part. Now you got x minus 6 times x plus 6 less than or equal to 0. How to solve? When is it less than or equal to 0? You must consider all the possible different values of x. So let's just write down these, what we call the critical values. Then consider, if you put in negative 1 million into the left-hand side, is it less than or equal to 0?
Yes.
Think about
it.
Negative 1 million minus 6 is going to become negative. Negative 1 million plus 6, the plus 6 can't do much, so it's still negative. So now you got negative times negative. Do you think it's negative or positive?
It will be positive.
Positive, exactly. So likewise, for all the numbers to the left of negative 6, it will just become a positive. So you put a plus sign over there. Okay, this region here, you put a plus sign. So now let's try again. Let's do another experiment. Let's say it's exactly equal to negative 6. What happens? If x is exactly equal to negative 6, this is a number line for x, by the way. When x is exactly equal to negative 6, well, that means that x plus 6 is equal to 0, right?
Yeah, so it's
this becomes 0.
0.
So it's equal to 0. Here we requested for less than or equal. So that means this one you can just put a solid circle. Just put a solid circle like this.
Okay.
Then let's try numbers in between negative 6 and 6. Let's just say a simple one would be 0. If x is equal to 0, let's try. What happens to your left-hand side? 0 minus 6 is positive or negative?
Negative.
0 plus 6?
Positive.
Negative times positive?
Negative.
So you put a minus sign. Likewise, then you just continue the last one. Let's 6 exactly. I think you should realize that when x is equal to 6, sub in over here, what do you get? 6 minus 6, which is
0.
0 times anything is 0 times something.
0.
So 0. Then you can, is it less than or equal to 0? Is 0 less
to,
than or equal to 0?
Yeah.
Yes.
yeah,
Yes. The answer is a yes. So you have to circle
shade.
shade. And over here, try another number. Let's say 10 million. Or however many zeros you want. Very, very, very big positive number. This entire region. Very big positive minus 6 is positive or negative?
Positive.
Very big positive plus 6.
Positive.
Positive times
So it'll
positive.
be more than 0.
More than 0. Yeah. So is it? So it'll be positive or it'll be positive. Then now we figure out the sign of all the different regions. Then which parts are less than or equal to 0? Here, here, and here. Correct?
Mm-hmm.
So therefore your answer should be -6 less than equal x less than equal to 6. This is the thing that's different about quadratic inequalities. Okay, is it difficult?
Uh,
Just
maybe if I do by myself.
yeah, just the key idea here is you can rewatch the video as well. Draw a line with the x values, then it doesn't always have to be x. Then you draw two lines which are the critical values. You let the first factor equal to 0, and then you get the two factors you equate to 0, then you solve for x, you get -6 and +6. Those will be your critical values you should put in. Then you plug in different numbers to the left, exactly at -6, in the middle, exactly at 6, or to the right. And then you check the sign, plus, minus, plus, minus. Then you conclude. This is one way to do it, or one way to do it. Let me show you a second way. I need to change screen now. Give me a moment. The second way to do this, just remove all the graphs, is to draw the graph of y equals x minus 6 times x plus 6. Can you see my decimal screen?
Yeah.
Can all? Good. So let's just look at the curve. Wow. The curve. Can you see that there's an x-axis here, y equals 0? This one,
Yeah.
blue one.
Yep.
Can you see that there are two parts that are above? Like this part is above and these parts are below.
Yeah.
Then when we ask for less than equal to 0, what are we actually asking? We're asking,
For
please
below.
look at the parts that's below. And
Okay.
what is the range of x values that correspond to the part that is below? So let me just zoom in. I think you can see it's from -6 to +6. Right? The y values now you see, you move down -2.822, -5.706, all these -10.04, or you try all the other numbers, you can slowly go and check. Negative, blah, 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 doesn't matter. They're all less than or equal to 0 because they're below the x-axis. But in this quadratic inequality, we're interested in the corresponding x values. So -6 to +6. Does it make sense?
Yeah.
Okay, good. So that's the other way. So let me just change screen back to my iPad. Hold on. Okay, so this is this, I'll just box it up like this. This one is method 1. Method 2 is to just draw a curve. Don't need to draw the y-axis. Don't need to draw the y-axis. Just draw the curve. You should know that it's a happy face, right? Because positive x squared. Then the two roots, -6 and +6. Then you want the part that is less than or equal to 0. So you just consider the part that is below. But you don't just look at the curve that is below, you focus on the shadow, the pink color here. So it's -6, +6, less than x. But wait, do you need to put an equal sign here?
Yeah.
Why need? Because here have already. The beginning of the question, they requested for equal, so you must also be consistent. Put equal. That's all. Okay?
Okay.
Okay, sorry. I think I can only cover section 1 and section 2. Let's move on. Let's move on. Yeah, not enough time. So sorry. Bad planning. Okay, let's go on to the next question, which is still on section 1. Let's try another example. Which one do you want? Then the rest will be.
Which one do I want?
Yes, section 1. Which question do you want?
Section 1, which question do I want? Or
Yes.
any? Yeah, any.
Any? Okay, then I will pick the more difficult one, question 4. Okay, then the rest will be your homework. The rest will be your homework.
Okay.
Okay, let's go. So question 4, negative 3k squared less than negative 27. Oh no, now it is so complicated. Don't worry. Let me just suggest to you how you can do this. Minus 27. I'm gonna plus 27 on both sides. What happens when you plus and minus 27?
0.
Cancel off your left with a 0. Good. So less than 0. So you get 27 minus 3k squared. That looks so funny. Let's compare with the previous working. Compare with the previous working. Like this. Just copy and paste the other side. Just now we got positive x squared. Now you got negative. It's not x anymore, it's a k. And it's not 1 anymore, it's a 3. Wow, so weird. How? 3k squared minus 27 more than 0. Very good. Exactly. Just flip the sign. Okay? Flip the sign. I would recommend to my students to really make sure that the coefficient, the sign of the coefficient of the quadratic term to be positive. It makes things easier. Now you got a 3, you got a 27. Do you notice anything common between them?
Divide by 3.
Yes. So we can factor our 3 first, then divide by 3. Do you need to flip the sign when you divide by 3?
No.
Don't need. Then 0 divided by 3, of course, still 0. This time is more than. So funny. How? Factorize. Good. K minus 3 times k plus 3, more than 0. Then how? I recommend, never mind. Method 1 may be a bit difficult. Let's just try method 2 straight away. Do you remember method 2?
We
Copy.
can try.
Try. Okay, go. Want to try? Yes. Happy face. Good. Be careful now. More than 0. What does it mean?
More than 0 should be above.
Exactly. But don't just shade above the entire thing. Should be above as in the left leg and the right leg. So you want the corresponding. Let me just draw a nicer graph. So something like this.
Okay.
So
okay.
Then you want this part here and this part here, but you don't just want those parts. You want the shadow. Can you see the shadow is here? Shadow is here.
Okay.
If you extend all the way, the quadratic curve actually goes all the way. So the shadow goes all the way to the right, all the way to the left. How do you represent it? It will be x less than minus 3.
Or x is more than 3.
Exactly. The direction that you move towards, you see the arrowhead, is the same as the direction of the inequality. Can you see that?
Yeah.
And you just need to make sure your variable is on the left. Variable left side. Answer on the right side. Okay. Then the direction will follow. It follows the direction of the shadow. The pink shadow. I use pink color. I'm referring to this pink shadow. Okay. Can?
Can.
So I show you 2 versions already. Just now it was less than or equal. Right? Less than or equal. Now I change it to a more than. And by the way, do you need to put in an equal sign?
No.
Don't need.
Question never give.
Correct. The question started with K. Another mistake I made here, should it be a X or should it be a K?
Should be a K.
Exactly. Okay.
I mean,
sorry.
I know what you mean.
Follow the letter given by the question. Okay, good. There is another example. The rest will be your homework. The rest will be your homework for section 1. Let's move on to section 2. Okay, section 2. Now is a factorizable quadratic. Let me just start a new page. Hold on. Section 2. I'll send you the PDF later. Don't worry if you cannot copy in time. Okay, section 2. Let's see. So 3x. Let's start with the question 1. 3x squared minus x less than or equal to 0. Can you see how you can factorize the left side?
X.
Factor out the x. Good. Left with 3x minus 1. Yes?
Yeah.
less than equal 0. Then, factored form already. The moment you reach factored form, straight away draw the curve. I think method 2 is the fastest way. Let's just do it. So happy or sad face? Happy or sad face? Positive x times positive 3.
Happy.
Happy face. Whenever the coefficient of x squared is positive, then you get happy face. So ax squared plus bx plus c.
Only
A
when
more than 0, happy.
Okay.
A less than 0, sad.
Okay.
Give you some tears. Okay, then happy. Just try to use the happy version. I think it's easier. So what are the two roots? 0, 1/3. How do I get that? Set each factor to 0.
Okay.
Then solve for x, right? Okay, then less than equal 0. Which part? Can you highlight for me which part you are looking at? Or just scribble anything? Correct, yes. Then you focus on the shadow. So therefore, it will be this region here, right? Correct? Then what's the answer?
X more than or equals to 0. And then less than more than less than or equals to 1/3. Wait, did I say that right? No. Wait. How?
Okay, you did. But I purposely okay, you said x more than equals 0. The idea is correct, but I would prefer if you read it in the other direction. 0 less than or equal to x. Why? Because now you can combine them together into one single inequality. And that's the expected answer. Okay?
Okay.
Can? Good.
Yeah.
Sorry, my 1/3. Not so nice. Then of course you need the equal sign because equal given by the question. Good. Next. Let me see which is a good question to do. Question 2 and 3 do as homework. Okay, later I'll tell you what questions we skip and then you will do those questions. Let's just skip 2 and 3. Those will be our homework. Then let's go to question 4. Okay, question 4. Now we got 3x squared plus 24x less than 12x. Oh no, how?
Minus 12x both sides.
Good. Then you're left with 3x squared plus 12x less than 0. Anything to factor?
3.
Divide by 3. So x squared plus 4x. 0 divided by 3 is
Factor
0.
out x.
Yes. Good. Very fast. Good. Less than 0. Then maybe you try. Continue writing. Yes. Plus 4 bring over. Minus 4.
And then
happy or sad?
Happy.
Good.
Then 0 is more than, so
here is less than. Okay, yes, perfect. Okay, so all you need to do is really just happy face, 0, -4. If you cannot work it out, what are the 0 and -4, then you do it step by step. Equate them to 0, make x a subject, -4, 0. Then after that, less than 0. So you focus on this shadow here. So answer is 0 less than x less than -4. Easy?
Yeah, okay.
Okay, right? Okay, not too bad. Let me see if I missed out any particular question. Any particular type of question? Okay, I think that's you can do this. The rest also you can do one. Okay, we're gonna move on to question 7. Let's look at question 7. 3x squared plus 8x plus 5. Wow, now there's a constant, right? Previously, all of my questions can factor out x. Now, can you factor out x? Cannot. The constant here. So how? Use calculator to help you to factorize. Don't bother trying to figure out yourself. 3x squared plus 8x plus 5. Use a calculator. I got x
plus
equal -1, x equal -5/3. So factorize, you get x plus 1 times 3x. Exactly. Perfect. Less than or equal to 0. Happy or sad face now?
Happy.
Happy face. So you draw x-axis, draw a happy face. What are your two roots? We already got it over here from the calculator. -5/3, -1. Okay, or should it be -1 then -5/3?
-1 then -5/3. Wait. Yeah. No, wait. No, sorry. Other way around.
Yes, you have to be careful. This one, when you're stressed during exam, you will make this mistake. Should be 5/3 and then 1 because smaller on the left and bigger on the right. Yeah, so now less than equals 0. Which part? The two shadows or the bottom? The bottom, yes, exactly. And then you focus on the shadow, which is this region here. Oh, so far, most of my questions are like in the middle. Okay. Then less than or equal to x, less than or equal to -1. That's it. Easy?
Mm-hmm.
Okay, good. Let's try question 10. Okay. Hey, actually, you know what? Wow, I can't believe it. Hey, your factorization skill is very, very good. That's why I can go through so fast. Okay. But I don't think I have time to start section 3. Do I have time? Let me think. Okay, you know what? Let's just go. Let's just go into section 3. So you can do the rest already.
Okay.
You know how to do the rest already. Let's just go to section 3. Let's go. Go. Wow, rushing through. Oh no. Section 3. Let's see. So for section 3, I don't think I can cover all 3 sections. So I'll just cover part 1. Part 1.
Okay.
So this is what we call the behavior, how to use the discriminant to find out the value of k. So let's read part 1. Find the range of values of k for which the equation in each of the following questions shown has no real roots. Okay, so what you need to understand is that x equal -b plus minus square root b square minus 4ac all over 2a. There are 3 cases to consider. 3 cases to consider, in particular, due to the discriminant over here. The b square minus 4ac can have 3 cases. What are those 3
Discriminant
cases?
is negative.
Yes. More
Because
than 0.
no root. Because if you square root negative, you cannot square root negative number.
Very good. Yes, exactly. This one is no real roots. In the future, if you're going engineering, actually you should know this. Square root -1 is actually what we call imaginary numbers. For now, you don't need to know. You shouldn't know this yet. It will.
Yeah, I don't know.
Yeah, don't bother with this yet. Just say
Okay.
no real roots. It's good enough. You cannot square root negative number. Good. Then this one will be equal roots. Equal roots meaning, because what happens when b squared minus 4ac equals 0? Take the square root of 0, you get 0. Right? Then it will be -b plus minus 0 over 2a. Plus minus 0 means essentially gone. You're just left with
minus b over 2a.
So you get one solution only. Right?
Okay.
But actually, it's not one solution. You can think of it as because quadratic equation x squared, when you got power 2, you're expecting how many solutions?
2.
2, right? But if you only get -b over 2a, one solution only, that's what we call equal roots, or what we call repeated roots. There are actually, we say that, it's a bit funny, but we say that there are actually 2 solutions. It's just that they happen to be the same. It sounds a bit funny. Yeah, so, the way we say equal roots or repeated roots. And more than 0 means real roots. 2 real and distinct roots. Sorry, let me write this down. 2 real and distinct. Distinct is just a funny way of saying this different because it's shorter and fewer letters to spell. Yeah, 2 real and distinct roots. Okay, so let's go. So for this question, part 1, we are asking you, no real roots, right? So we have to focus on the quadratic. 4x squared minus 3x minus 3k plus 2. Can you tell me how many letters of the alphabet do you see?
2.
There's x and there's k. Exactly. Now, which is the variable? Which is the constant? X and k, which is variable, which is constant?
Wait, what is variable and what is constant?
Variable is like, for example, y equal f of x. Then x and y are the variables.
Okay, then x is the variable, then k is constant.
Very good. That is what you said first. Let me write down. X is a variable, k is constant. However, I am sorry, but that is true only in this current state. When we are going to use the b squared minus 4ac and use these 3 rules, in particular, this is no real roots, so we are going to focus on this case. We are going to change our point of view, our perspective. We're going to say that k is now the variable. What do I mean? Let me demonstrate. Now, we know that there is no real roots. So we write for no real roots, the discriminant b squared minus 4ac. Okay, let's just write down what's a first. A is 4, b is -3, c is, what is c?
Minus 3k plus 2.
Very good. It is not just plus 2 on its own. It is not just minus 3k on its own. It's together, everything. Then we just use the formula b squared minus 4ac. So b bracket square minus 4 times a times c. What is it? No real roots? Which case?
No real roots is less than 0.
Very good. Less than 0. Okay. Then we have to now solve for k. Do you notice? No more x. Let me write down. No more x. K is now the variable. Okay. Must change perspective. That's why I draw a line here. Just now k is constant. Now k is variable. You solve for k. Does that make sense?
Yep.
Okay, then we try to simplify this. Negative 3 squared, 9. Minus away 4 times 4, 16. Multiplied by negative 3k plus 2. Less than 0. Let's just use back to black color. 9 minus 16 times minus 3k. Negative times negative, positive. 16 times 3, 30 plus 18, 48. Okay. Then negative 16 times 2, negative 32. Did I calculate correctly?
Yeah.
I hope so. So 9 minus 32. Let's calculate that. What's that? Negative 23. So 48k less than minus 23 bring over positive 23. How to solve for k?
Divide by 48 both sides.
Yes, exactly. That's it. Done. Easy?
Okay.
Yeah, that's part 1. Section 3 is easier. Linear inequality in k. So what you realize about this quadratic inequality about k? Do you see k squared?
No.
No, right? It's just power 1. That's why I call this linear. Linear. Just now I gave you an example of a quadratic. I believe it's over here. Quadratic inequality in k. There's a power 2. Right? So so you have seen almost all the versions of questions already. Maybe section 4 then will be more difficult. So I think you understand, you learned before, is it? This one, these 3 cases, more than 0 equals 0. No? Oh, okay. Then your Emacs is very strong. Very good, very good. Okay, so for part 2 and part 3, right, they are the same thing. You just have to consider case by case. For part 2, it will be, let's read the question. Find the range of values of k for which the equation in each equation shown has 2 distinct and real roots. This part
more
here.
than 0.
So more than 0. All you need to do is to identify what's your A, B, and C, plug in the formula for the discriminant, then change the symbol here. The only thing you need to change is this guy here. Change from less than 0 to more than 0, or change to equal to 0. Part 3 will be equal to 0. Part 2 will be more than 0. Part 1, which is what we just did, is less than 0.
Okay.
Do you think you wanna try all questions as homework?
Sure.
Can Okay. Or should I? Okay. I'm a bit not confident. I don't feel safe. I think I better go through one more question. Let me think. Which is better? I'll do question 2A.
Okay.
No extra charge. No extra charge. I'm still charging 2 hours only. Okay.
Okay. Thanks.
Yeah, no worries. Yeah. So this, let's identify what's my A.
Your A is 1.
What's my B?
Minus 2.
What's my C?
Negative 2k plus 1.
What's my discriminant formula again?
B squared minus 4ac.
Good. Okay, so now they tell you they want 2 distinct and real roots. So we need the b squared minus 4ac to be less than 0, equals 0, or more than 0. Which one?
More than 0.
This one wrong. This one wrong. This one correct. Okay, more than 0. Okay, let's go. So b squared minus 4ac, use the formula. B squared minus 4 times a times c. What is it again? We want 2 real and distinct roots, so it must be more than 0. Okay? Then expand on negative 2 squared, positive 4. Minus 4 times 1 is just minus 4 times minus 2k plus 1, more than 0. Do you want to try? Okay, I'll just explain I think to save some time now. Negative 4 times negative 2k. Negative times negative gives you positive. 4 times 2 gives you 8. Don't forget the k.
Okay.
Negative 4 times positive 1 minus 4. What a coincidence. 4 and minus 4 cancel off. 8k more than 0. How to solve for k?
Divide by 8 both sides.
0 divided by 8. Yeah,
Is-
I divided by 8, so it's just a 0 log. Divide by 8. Okay.
Okay.
Okay, I'll try one more. Question 3a.
Okay.
Question 3a. Now it's minus 2k x squared minus 2x minus 2k plus 1 equals to 0. A equals,
Minus 2k.
B equals,
Minus 2.
C equals.
Negative 2k plus 1.
Okay, discriminant b squared minus 4ac. This
Yeah.
time, let's read the question. What did they say?
Equals to 0.
Yes. Coincident roots. Sorry, I didn't mention coincident. Sorry. I don't know why there's so many funny words, but they're all synonyms. Equal, repeated, coincident. They all mean the same thing.
Okay.
Okay. Yeah, so equal to 0. Yes. So now let's go on and use the formula. B squared minus 4ac. Oh, sorry, this one not this might not be linear. Equal to 0. Okay, let's expand this. Negative times negative gives you positive. 2 squared is 4. Minus 4 leave alone. Maybe I'll just multiply the two negatives first. Then I'll get a positive. 4 times 2k. Okay, you know what? Let's go a bit faster. 4 times 2 is 8, right? So this is just 8k times minus 2k plus 1 with bracket. Notice this time is an equation. So I think you know how to solve this kind of question. Quite easy, equation, quadratic. Not inequality, nothing new. So 4 plus 8k times minus 2k, you get negative 16k squared. Then 8k times positive 1, you get plus 8k equals 0.
Okay.
I think you know how to solve it.
Calculator.
Yes, exactly. Let's just rearrange it to negative 16k squared plus 8k plus 4 equals to 0. Then I divide by negative 4. So let's see, I'll get a positive 4k squared. Divide by negative 4, I get a negative 2k. Divide by negative 4, I get a negative 1 equals 0.
Okay.
Right? Then I think you can solve already. Not exact answer. I didn't plan
good.
it, so.
0.80. Yeah, can.
Can, okay, good. I also got the same answer. Negative 0.30901. And the other guy, or k equals, what was that? 0.80901699944. Okay,
Nice.
good. Wow, nice. I made it in time. Okay lah, I exceeded by 9 minutes. Don't worry. Yeah, so your homework I'll just send it to you later. Okay. You can do section 1, section 2, section 3.
Okay, can.
Okay, can. Great. Next lesson, do you want let me just stop the recording first.